In the last video, we took a look at the slope as a very interesting and unique characteristic of a linear function. The slope, again, is a mathematical description of the steepness of a line. Now, if we look at how steep this particular line is, keep in mind that I could draw another line, for example, down here, which is the same steepness or has the same slope. From a mathematical perspective, these two are what we call parallel lines. Same steepness, but not actually the same line, and they never end up crossing. So the slope itself, while a super important characteristic, is not enough to what we call uniquely define a line. It will tell you an important characteristic, but not enough to just say this is exactly the line that I'm talking about. To do that, you need to have the slope and one other point that will be able to firm up, I guess. I'm talking about the line with this particular steepness that goes through this point, not the line that goes up here. So the slope and one other point is enough to uniquely define a line. Now, in mathematics, we have a very interesting form of a line that we use a lot, and that's what we call the slope-intercept form of a line. The general equation of a linear function will look like this: y equals mx plus b. Sometimes you'll see it written in function notation like this: f of x equals mx plus b. Remember, our outputs can be written either as y or as f of x. In these examples, the y, the inputs and the outputs have to be part of the equation. However, the slope and the y-intercept end up being important points that are unique to any given line. So m, like we saw earlier, represents the slope. The b represents our vertical intercept, or our y-intercept if you like talking about it that way better. So as long as you can get an equation into this y equals mx plus b form, you'll be able to say, hey, I know the slope, hey, I know the y-intercept, and then you could answer all sorts of things about your graph. This particular form is particularly nice when you want to draw a graph of a linear function. So let's take a look at how we would do that. If you want to draw a graph of a linear function, the first thing that you want to do is to make sure that your equation is in y equals mx plus b form. For us, that means that the y has to be by itself on one side of the equation. Notice both in problems 4 and 5 here, the y is already by itself. This is awesome because it makes it very easy now to do step 2, which is identify the slope, which is the m value in the equation, and the y-intercept, which is the b value in that equation. So if we take 4 here as an example, we have the y by itself, y equals 3/4 x plus 2. My slope, or m value, is the 3/4 because it's the coefficient in front of the x. The y-intercept, or b value, is -2. Notice that we had to take the sign of the number in front of the 2 there. That is an important part. That is an important part of what it is that we need to work on. So here, m is equal to 3/4, b is equal to -2. All right. Once you know the slope and the y-intercept, the next thing that we want to do is to actually start to sketch our graph. When you go to sketch your graph, step 1 is we need a point to put on there. The slope is only a relationship between 2 points, so we can't use the slope yet. We start with our y-intercept. So we're going to plot our b value on the y-axis, because that's what an intercept means. So here, this is my x-axis, this is my y-axis. My y-intercept is -2, so I'm going to go down 2, and I'm going to put a starting point right there. Once you've put your b value on the graph, now we're going to use the slope. And here it's really helpful to think of it as rise over run. You're going to use the slope to come up with your second point. Now, what's really important here is you have to start at the y-intercept that you already have. That's your starting point because I know it's on the graph. So here's my y equals -2. For my slope of 3/4, I'm going to go up 3, so up 1, 2, 3. And then I'm going to run 4 over 1, 2, 3, 4. So from here, I go up 1, 2, 3 spaces, and then over 1, 2, 3, 4. And there's the second point in my graph. Now, once you have 2 points, that's really all you need to sketch the graph of a line. So just connect the dots. And that is the graph of your line. So having your equation in this y equals mx plus b form makes it very, very fast to be able to sketch a graph. Let's try another example here. Y is by itself, so we identify our slope, which is negative 2/3, and our y-intercept, which is 4. We come to our graph and plot the y-intercept as our starting point. In this case, the y-intercept was a positive 4, so we're up here. Then we're going to use the slope as rise over run. Now, in this particular problem, notice that we have a negative. That's really important. The negative I like to think of the negative just always as going with the top number. It could go with the bottom as well, but I just find that from a reasoning perspective, it's a lot easier to think of the negative as being with the top. So what I'm going to do here is I'm going to rise -2, so I'm going to go down 2 places. And if you think of the negative as always being with the top, then you're always going to run to the right, so that helps me a lot. So rise -2, so I'm going to go down 2 places and then run 3. 1, 2, 3. There's my second point in my graph. So that works out really well. Oh, erased too much there. So from 4, oh my gosh, oh, we're doing it here. 1, 2, 3, 4. There's my 4, down 2 over 3. There's my second point. And now that I have 2 points, I can connect the dots and I'll have the equation, or I'll have the graph of a line. So that's basically all there is to it. A couple of things that might look a little strange to you the first time you see, so let's use that as an example. In this case, we have the y by itself, so we're in good shape, so we can identify the slope and the y-intercept. The slope is always the number in front of the x, which in this case is 3. The y-intercept is the plane number, and there's not one, so think of your y-intercept as 0. When we come over here to sketch our graph, notice that a y-intercept of 0 is going to mean that my graph is going to go right through the origin, and there's nothing wrong with that at all. That's exactly fine. From my starting point, which in this case is right here at the origin, I want to do rise over run. Well, the next problem is my slope is not a fraction. So life is way easier if you take the time to go ahead and think of it as a fraction. So I'm going to think of this as 3 over 1. What that means is from my starting point intercept, I'm going to rise 3, so up 1, 2, 3, and go over 1. There's my second point, connect the points, and I have the graph of my line. For the next example here, again with number 7, the y is by itself, so we identify our slope as the coefficient or number in front of the x. Now in this case, there is no number in front of the x, but that means it has to be a 1x. Because if it was 0, the x would totally be gone. So if there's no number in front of the x, it's always a 1, so in this case, that means my slope's going to be a 1. Thinking ahead a little bit, remember we're going to want to think of our slope as rise over run, so think of that as 1 over 1 in this particular case. Now back to my original equation here, y equals x minus 3. My y-intercept is going to be -3, so that's where I start when I plot my point. Down 3, there's my y-intercept. Slope is 1 over 1, so up 1 over 1. There's my second point. Connect the dots. Problem number 8 is a little bit trickier. Notice here we have a real big problem, and that is that my y is not by itself. So because the y is not by itself, you need to get it by itself before you can identify the slope and the y-intercept. Don't try to do it before then. So right now I want to get the y by itself. It's attached to the 3, so the 2x out here is a little bit weaker link. So I'm going to move it over to the other side of the equation by minusing 2x. So on the right side, that leaves me with 3y. Or sorry, on the left side. On the right side, I'm going to go ahead and write it as -2x plus 6, because I usually like to see my, I like that y equals mx plus b, so I want the x term to come first. The next thing that I'm going to need to do is divide each side by 3, because I need to finish getting the y by itself. So here when I do that, keep in mind that we're dividing a sum by 3, so we have to divide each individual term by 3 when we do that. It helps me to go ahead and break it up right now, because we need to identify the slope and y-intercept. So in this case, I have to do the -2x over 3, so I can think of that as -2/3 x. And then I have to do plus 6 divided by 3, which actually works out to be a nice 2. So when I'm looking at this, I can now, that the y is by itself, identify the slope, which is -2/3. And I can identify the y-intercept, which is 2. And that wasn't immediately apparent when you looked at the original problem. So from there, we graph our y-intercept. There at 2. And then I use my slope of negative 2/3, which means I'm going to go down 2 and over 3 places to get my second position. There's our 2 points. We connect the dots. There's the graph of my line. The last problem here with problem number 9 is y equals 3 minus 2x. The only caution I want to remind you of is the slope is always the number that's in front of the x. If you want to turn it around, that's great. Remember that the negative is with the 2, so that would be rewritten as a negative 2x. The 3 was a positive, so that would be plus 3. So when you identify your slope and your y-intercept, the slope's the number in front of the x, which was negative 2, and the y-intercept was the plane number, which is 3. And you can grab that from the equation in its original form, but if you find that a little bit confusing, just make sure that you get that turned around so that you can get the m as that value in front of the x. Once I'm there, same deal that we've been doing everywhere else. Start by plotting the y-intercept because that's an actual point. So there's my point at a y-intercept of 3. Then I'm going to use the slope to grab a second point. Right now it's not a fraction and I want to think of it as rise over run. So I'm going to think of it as negative 2 over 1. Because my slope is negative, I'm going to go down 2 and then over to the right 1. There's my next point and I can go ahead and connect the dots. Another piece of interest that I think is super helpful, I really recommend double checking your slope and your line as a final check that you did all of your motions correctly. Remember, if you have a negative slope, you should be looking at a decreasing or downhill curve. Here I had a negative slope and I have a decreasing or downhill curve. Here in number 7, I had a positive slope and it's an increasing or uphill line. And over here, I had a positive slope and it's an increasing uphill type of line. And so it helps me that way, especially when there's negatives involved, just as a last minute sanity check. If the slope was negative, the graph of my line should be decreasing. So check for that before you finalize your solutions.